Welcome to my video on properties of determinants. In this video, I'm going to look at the theorem. If matrix A and matrix B are n by n matrices, that's our square matrices, then the determinant of the product of A and B is equal just to the product of the determinants of the individual matrices A and B. And what I want to do is I'm not going to offer a proof of this, but I am going to go through an example that will illustrate this. So let's look at. So here's our example. We're going to let matrix A be equal to 1, 2, 3, 4. Matrix B be equal to 2 minus 1, 1, 2. Okay, first thing we need to do is we need to determine the determinant of A. And so for a 2 by 2 matrix, it's relatively simple. We can just cross multiply. Main diagonal minus this diagonal. So that's going to be equal to 1 times 4. And I've covered matrix multiplication in a previous video if you want to reference back to that, if you're rusty on that. Determination of a determinant and matrix multiplication. And then minus 2 times 3. So that's equal to 4 minus 6. That's equal to minus 2. So that is the determinant of the matrix A. Now let's do the determinant of matrix B. And B is 2 minus 1, 1, 2. And once again we do the cross multiplication. This diagonal minus this diagonal. So that's going to be 2 times 2 minus 1 times 1. So that's 4 plus 1, that's equal to 5. So there is our determinant for the matrix B. All right, the next phase in this example is going to be determine the product of A and B. And so we've got A is 1, 2, 3, 4 times 2 minus 1, 1, 2. And we're going to do the multiplication now. So multiplication, we're going to take the first row times the first column, and that's going to be equal to the first element. So that's 1 times 2 and plus 2 times 1. So that's our first element. Now for our second element, we're going to take this first row times the second column. So that's going to be 1 times minus 1 and plus 2 times 2. Now for our third element on the lower left, we're going to take this bottom row times the first column. Let's multiply that out. So we got 3 times 2 plus 4 times 1. And then our final element is going to be 3, 4 times minus 1, 2. So that's 3 times minus 1, and then plus 4 times 2. Let's get this out here. All right, so in looking at this element right here, that's 2 plus 2, and that's going to be equal to a 4. Look at the lower left-hand corner here. 6 plus 4 is going to be a 10. This element is going to be a 4 minus 1, that's going to be a 3. And then here we have got 8 minus 3, that's going to be a 5. So there is our A product B matrix. So now let's take the determinant of that. So the determinant of AB is going to be equal to 4, 10, 3, 5, and we know that that's just a cross multiplication. So we take that minus that, and that's going to be equal to 4 times 5 minus 3 times 10. Okay, so that's 20 minus 30, That's minus 10. So that's what we have so far. Okay, so now let's check and make sure that this theorem is illustrated here. So we say AB is equal to the product of the determinants. So that's what the theorem told us. Now we know from this what we just completed, the determinant of the product of A and B is minus 10, and A, we determined the determinant of A is minus 2, the determinant of B is 5, so minus 10 does equal to minus 10, and that illustrates that this theorem at least worked in this one example, and we know it works in all examples, but it is a good way of reviewing that. All right, well, I hope you got something out of it and learned a little bit about the properties of determinants and what to do with when you multiply them out. If you did, give me a like, thumbs up, subscribe to my channel, and thank you for watching.